In a lab in Tianjin, China, a steel reactor the size of a household fridge is fed nothing but the carbon dioxide pouring out of a factory smokestack, and out the other end comes a white powder that is chemically identical to the starch in your bread, your rice, and your bowl of potatoes. Before we go deeper, if you want to catch the next one of these before everyone else does, subscribe and turn on notifications. No field, no sun, no corn. Just a pipe of gray gas going in and food coming out the other side. And I need you to understand, before we go one step further, that this is not a slick concept render or a slide in some investor deck. It actually happened. Someone built the machine. They ran the gas through it. And they scooped out real starch at the end. Let that land for a moment. The anchor for all of this is not a rumor. In September of 2021, the Chinese Academy of Sciences, working at its Tianjin Institute of Industrial Biotechnology, published a paper in the journal Science, one of the most serious scientific journals on the planet, saying they had built starch from carbon dioxide inside a machine, not grown it, built it. And here is why that single sentence should stop you cold. For 10,000 years, exactly one thing on this earth could make starch out of thin air. A living plant. Wheat, rice, a stalk of corn in a field. That is the entire list. Sit with that for a second. For 100 centuries, starch meant a plant. Only a plant. Every loaf of bread that has ever been baked, every bowl of rice ever served, traces back to a leaf catching sunlight. So how on earth did a lump of metal and pipes do a plant's whole job? Now that question, how one Chinese lab quietly did something the whole world assumed only nature could, is exactly the kind of thing that should make you pause. Because this reactor is not a one-off. It is one move on a much bigger board. The same country turning smokestack gas into food. At the same moment, rewriting the rules on energy, on chips, on how things get manufactured. And by the time the headlines catch up, the winners are usually already decided. That is the gap I keep watching people fall into. They react to China's rise a year too late to do anything with it. If you want to close that gap, there is a strategic guide I keep coming back to called the China Signal. It decodes what China is actually building, sector by sector, energy, technology, manufacturing. So you can spot these shifts while they are still early, understand why they matter, and read where the world is heading instead of scrambling after the fact. Scan the code on screen, or the link is in the description. Okay, back to the reactor and to the real puzzle. Why did this take until 2021 at all? To answer that, you have to see why farming was always the bottleneck. Picture a corn plant for what it really is. A slow, messy solar factory. It spends months standing in a field, pulling in sunlight, water, and carbon dioxide, and slowly stitching them into sugar. It works. It has fed us forever. But it is shockingly wasteful. Of all the sunlight a corn plant catches, only about 2% ever ends up as food you can eat. 2%. The other 98% slips away as heat and waste, and the plant just keeping itself alive. And here is the part that reaches all the way to your own kitchen table. That single number, that 2%, is the reason feeding a planet has always cost the same three things: more land, more water, more fertilizer. Every extra mouth means another acre plowed, another river tapped, another truckload of chemicals spread on soil. The inefficiency of the leaf is baked into the price of everything you eat. So for decades, chemists asked the obvious question: if a plant is this wasteful, why not skip the plant? Build the starch directly, in a tank, cleanly. And every time, they hit the same wall. Starch is not a simple molecule. It is a long, precisely folded chain, thousands of sugar units linked and coiled in an exact order, like a paragraph where every letter has to be in the right place, or the whole thing is gibberish. A living cell does that folding with machinery it took evolution billions of years to build. Doing it in a beaker with no cell was considered so close to impossible that most serious labs simply did not try. That is why nobody expected this particular wall to fall. And certainly not from a fridge-sized box in Tianjin, because the team there did something quietly radical. They did not try to copy the corn plant. They replaced it. They drew up a blueprint, a kind of chemical assembly line, and gave it a name, ASAP. And ASAP does not photosynthesize the way a leaf does. Its very first move takes that incoming carbon dioxide, the raw smokestack gas, and turns it into a simple alcohol, the same kind of liquid you would find in a bottle of antifreeze. And that alcohol is where the real trick begins. And that alcohol has a name, methanol. The same simple liquid you would find in a bottle of antifreeze. And the reactor does not grow it the way a plant grows anything. It assembles it. An ordinary industrial catalyst, the exact same kind refineries already use to turn gas into fuel, grabs the incoming carbon dioxide and snaps it into methanol. No living cell, no sunlight, no soil. Just chemistry you could run inside a factory, right next to the smokestack the gas came out of. That is step one. And honestly, step one is the easy part. Then comes the leap. Because turning methanol into real starch, the actual, edible, chain-folded starch in your bread, is where every lab before this one hit a wall. Starch is not a simple molecule. It is a long, precisely folded chain, and a living cell spends enormous effort getting every link in the right place. So the Tianjin team did something a plant would never think to do. They built their own assembly line. They called the whole blueprint Albasa Sa-Pi, the artificial starch anabolic pathway, and it runs on 11 enzyme reactions. Just 11. Here is the part that makes chemists lean in. Those 11 enzymes did not come from one organism. The team went hunting across nature, pulled the single best enzyme from this bacterium, the sharpest one from that plant, another one from some microbe entirely, and snapped them together like taking the best single part out of 11 different machines and bolting them into one. Each enzyme does one clean job. Grab the methanol, bend it, pass it down the line, fold it up into starch at the end. Now hold that against how a corn plant does the same job. A cornfield needs roughly 60 steps. 60. All that machinery a plant carries just to inch sunlight and air toward a single kernel of starch, month after month, at about 2% efficiency, that slow green solar factory. The Tianjin reactor threw most of it in the bin. Read that again. Nature, 60 steps. This lab, 11. And when they measured it, the number that came back is the one that genuinely rattled the field. In the lab, this artificial pathway made starch about 8.5 times more efficiently than a cornfield does. Not 8.5% better. 8.5 times. Same starch. Same carbon dioxide going in. One path took months and half a field. The other took a box on a bench. Try to picture what that means in space. 1 cubic meter of this reactor, a box you could stand next to, about the size of that household fridge, could in theory produce what 1/3 of a hectare of corn produces across an entire growing season. A whole plot of farmland, sun and rain, and months of waiting, squeezed into a metal box on a bench. No field, no weather, no season. Stack a few of those boxes in a warehouse, and you have replaced a farm you would need a truck to drive across. Now let me be straight with you, because this is exactly where most videos would lie to you. A lot of this arrived loud. It came through Chinese state media first, wrapped in the language of a national triumph. And when a claim shows up already wearing a medal, healthy skepticism is not cynicism. It is the right instinct. So here is the honest shape of it. This was a bench-scale demonstration. That means it worked on a lab bench, in tiny amounts, proven once, not in a plant feeding a city. The enzymes are expensive to produce. And the whole chain still needs large amounts of clean energy to run, because you do not get starch from carbon dioxide for free. You pay for it in power somewhere upstream. Picture the distance between one test tube and the bread aisle of a supermarket. That is the gap we are talking about. Scaling this from a beaker to a bakery is an enormous engineering climb, and nobody has crossed it yet. But, and this is the part that cannot be walked back, the machine exists. It ran. The powder that came out the other end is real starch, chemically identical to the starch in your rice and your potatoes. Not a simulation, not a press release, a white powder you could, in principle, bake with. The limits are real. The starch is also real. Both things are true at once, and that is the honest place to stand. So let the chemistry settle for a second, because the chemistry was never really the scary part. 11 enzymes, a fuel catalyst, a box the size of a fridge. That is a fascinating story on its own. But it is not why Beijing is keeping this off the billboards. The real question was never whether the reactions work in a beaker. The real question is what happens to the people who have quietly fed the world for 100 years, the moment food stops needing a farm at all. Because think about who that is. For an entire century, one place has held the world's food supply in its hands. The American Midwest, those endless flat oceans of corn and soy, and the global agribusiness giants built on top of it. Detroit built cars. The Midwest built dinner for America and for a long list of countries that quietly lean on it. Their power was never really about seeds or tractors or trade deals. It rested on one assumption so old that nobody bothered to question it. That starch comes from soil and sun and a season. That to feed people, you need land, and the right land is theirs. A fridge-sized reactor in Tianjin has just put a question mark over that one assumption, the single thing that made them untouchable. And once you pull that thread, the whole map starts to move. And once you pull that assumption out, the whole floor tilts. Because for 100 years, the rule was brutally simple. Whoever owned the best dirt owned the world's dinner table. Rich soil, steady rain, a long growing season. That was power you could not fake and could not rush. It is why a stretch of black earth running through Iowa, Illinois, and Nebraska quietly became one of the most strategic places on the planet. The American Midwest. Endless combines crawling across the grain belt, rivers of corn and soy pouring into silos, then into container ships stacked high at port. Around all of it grew the global agribusiness giants, the seed companies, the grain traders, the fertilizer empires. They did not just sell food. They sat on the valve of the world's calories. And their entire kingdom rested on one quiet assumption. That starch, the base carbohydrate under bread, rice, noodles, half of what humanity eats, comes from a plant, standing in a field, drinking sunlight for a season. Now take that assumption away. Here is the payoff of everything we have walked through. If that little reactor in Tianjin ever scales, and that is still a real if, then food could be manufactured the way we manufacture fuel. Not grown. Manufactured. Think about what that word actually means. A refinery does not care if it is raining. It does not need spring, or good soil, or a border on the right side of the equator. It just runs. Feed it the raw material, run the reactions, collect the product. If starch becomes that, a thing you produce in a stainless steel tank in a windowless building, then you can make it indoors, anywhere, in a desert, on an island, in a country with almost no farmland at all. You have cut food loose from weather, from soil, and from any line drawn on a map. And that cracks open 3 consequences, each one bigger than the last. The first one is about survival. A country that can brew starch inside a reactor is a country that cannot be starved. Sit with that. For all of history, you could squeeze a nation by cutting off its food. A drought could break it. A blockade at sea could bring it to its knees. A single failed harvest could topple a government. But a factory that turns carbon dioxide into carbohydrate does not fail because the rain did not come. Think about what that does to a country that can no longer be starved out. Every siege, every embargo, every export ban that ever bent a nation to someone else's will, that lever just gets a lot weaker. And food security like that is not only something China could keep. It is something China could sell, export it, build the reactors somewhere else, and hand a hungry region a supply nobody can cut. The second consequence is almost poetic. Look at what this machine eats. Its raw material is carbon dioxide, the exact gas we are spending trillions trying to bury, scrub, and hide. The smokestack exhaust we treat as poison becomes the feedstock for a meal. A system that takes the thing warming the planet and folds it into the white powder that is chemically identical to the starch in your bread, your rice, your bowl of potatoes. An emission turned into dinner. If that ever runs at scale, the pollution problem and the food problem start solving each other. The third consequence is the quiet one, the handover. For a century, control of the world's food lived in farmland, in acres, in weather, in the grain belt. Pull food into a reactor, and control starts sliding somewhere else entirely. It slides toward whoever owns the machines, toward whoever owns the enzymes, and most of all, toward whoever owns the mountain of clean, cheap energy it takes to run the whole chain. Power over food stops being about who holds the best dirt and starts being about who holds the best reactors and the electricity to feed them. That is not a small adjustment to the map. That is a new map. Now remember where we started. A pipe of smokestack gas going in and food coming out. For 10,000 years, that sentence was impossible. For 10,000 years, starch meant a plant and a season. It meant a seed in the ground, months of sun, a harvest, and a prayer that the weather held. Only one thing on earth could turn thin air into the stuff that feeds us, and it was green, and it was alive, and it took its sweet time. Then, in a lab in Tianjin, for the first time in human history, starch meant something else. It meant a chemical recipe. 11 steps, written down, repeatable, run in a tank the size of your fridge. And yes, hold on to the honesty. Much of the noise came through Chinese state media, and skepticism is fair. This ran at bench scale. The enzymes are expensive. The gap between that beaker and an actual bakery feeding actual people is enormous, and it is not yet crossed. But strip all the hype away, and something hard is still standing. The machine exists. It ran. The powder is real starch. That part cannot be walked back. And this is exactly how technology curves work. They lie flat for a very, very long time. A beaker. A bench. A limit that the smartest labs on Earth stared at for decades and called near impossible. Flat, 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 for so long that everyone stops believing the line will ever move. And then, all at once, it is not flat at all. It bends and it goes vertical. And by the time the rest of the world looks up, the shape of everything has already changed. We are standing at the bottom of that bend right now. And the whole thing leaves one honest question on the table. The same energy that would run these reactors is the energy fuel refineries fight for too. So tell me below, which one falls first? The farm, or the fuel it now fights for power? Drop your answer in the comments.